So let's look at a final example. Professor DePorto believes there is a positive linear relationship between midterm examination grades and final examination grades for students taking his Introduction to Statistics course. A random sample of 26 students who have taken both exams produced the following data pairs. Okay, so we have midterm exams for 26 students, and then we have their final grades. Midterm grades and final grades. So the student received a 39 on their midterm, and the student received a 17 on the final. The student received a 28 on the midterm, and that student received a 42 on the final, and so forth. We're going to construct a scatter diagram. We're going to calculate the sample correlation coefficient R. We're going to find R squared and interpret its meaning. That should say R squared. That shouldn't say R2, it should say R squared and interpret its meaning. So, okay, let's take a minute. We're going to put the data into our calculator and construct a scatter diagram. So, stat, edit. I am going to clear out the data that we've had put in our list for the life expectancy and average length of schooling. Okay. Okay. So I'm going to put the midterm grades in L1 and the final grades in L2. So 39, 28, 32, 35, 30, 42, 34, 36, 22, 33, 22, 38, 29, 50, 16, 41, 43, 44, 39, 30, 24, 16, 29, 33, 44, 39. And now the final grades in L2. 17, 42, 30, 24, 15, 39, 16, 15, 19, 32, 39, 20, 25, 42, 36, 37, 35, 40, 21, 44, 11, 17, 19, 15, 29, 35. Okay, to calculate our scatter diagram, we're going to double check our settings in StatPlot. So one plot is on, the other two are off. Hit enter on the one that's on. Make sure it's flashing on. Type should be set to scatter diagram. X list should be where your X values are. And Y list should be where your Y values are. Let's talk about why the midterm is X and the final is Y. Going back to the example and reading what this is all about, the purpose of doing this problem is so that Professor DePorto believes that there's a positive relationship between midterm exam grades and final exam grades. He wants to check whether or not what the student gets on the midterm has any influence on what the student gets on the final. Is there a correlation there? Now, what should be the independent variable? It's the thing that comes first. And since the midterm comes first, the midterm belongs in the X list, L1. Once that's all set properly, you're going to quit this. You'll hit zoom. Oh wait, before you do that, press Y equals and delete the linear equation from the previous example. That should be gone before you look at the scatter diagram. Now press zoom 9. Okay. Hard to tell. Well, let's take a look at what R comes out to be, because to me this kind of looks rather random. Perhaps things are slightly grouped in a positive way. The points are slightly positive, moving up to the right as we look at the graph from left to right. But let's take a look at R squared to know really for sure. If we press Stat, then go over to Calc, then go down to number 4. Okay, X list L1, Y list L2, frequency list is blank, store regq blank, Calc, enter. Okay, R comes out to be 0.27 when rounded to 2 decimal places. And R squared, 0.07. Very small influence. Okay, so let's put these into words. Going back to the PowerPoint. We're going to calculate the sample correlation coefficient R, which is what we just did. We're going to find R squared and interpret its meaning. So the correlation coefficient came out to be 0.27. The coefficient of determination, we can simply look at the R squared line on the calculator, and it was 0.07, which is 7%. To interpret it, we say that 7% of the variation in the final exam grade, that's the dependent variable y, is influenced by the midterm grade, which is independent variable x. 7% of the variation in the exam grade is influenced by the midterm grade, which is it's not a very high percentage at all. So Professor DePorto can probably conclude that what a student gets on their midterm does not have a great influence on what the student gets on his or her final. The remaining 93% of variability is due to other unexplained factors outside the scope of this problem. So you've got only 7% influencing final exam grade. The remaining 93% is outside of the scope of the problem. Okay, we're going to also calculate a regression equation y prime for this example. So let's go to the calculator again. This is the output that we get when we run linreg ax plus b. And to find the linear equation, we have to look at a and we have to look at b. When we look at a and round it to 2 decimal places, we have 0.32. When we look at b and round it to 2 decimal places, we have 16.70. Okay, so 0.32, 16.70, and plugging those values into the equation for a and b, we have y equals 0.32x plus 16.70. Okay, so if we come up with an equation to use as a predictor, a linear model to use as a predictor, we can now answer a question based on predicting a final exam grade if we know the midterm grade. So Linda received a 24 on her midterm grade. Use the regression equation to predict Linda's final exam grade. So if the midterm grade, which is the x, is 24, we simply plug in 24 for x. So 0.32 times 24 plus 16.70, and that's about 24.38, or if we were to round to the nearest whole number, that would be a score of 24. So Linda's predicted final exam grade is 24. Let's put 0.32x plus 16.7 in for the y equation in the calculator. So 0.32x plus 16.7. So press y equals 0.32x 16.7 plus 16.7. Okay, we press the graph key, and there's our line going between the points. Some of the points are above and some of the points are below. Now, because our correlation coefficient and our coefficient of determination were both low, they weren't exactly very high scores for very high measures for those two values, it may be unreasonable to use this linear equation as a predictor. So therefore, you would answer parts D and E to the best of your knowledge, but in reality, thinking about it, it's probably, I would not bet that 24.38 is a very good predictor, because the R values and the R square value came out to be very low numerically. So that's basically what the end of chapter 4 is all about. You're going to be creating linear equations, and you're going to be using linear equations to make predictions. So you'll see this in web work, and you'll see it in your homework, and also available are the practice test examples that you can practice problems based on this stuff. So if you have any questions, you can email me, post them in the discussion forum, and I'll see you at the next lecture.